Hello students, the next chapter is loop structures in C. So for any programming language, the loops play a very important role in writing most of the programs. So there are many situations you will see where it is necessary to execute a group of statements repeatedly in the same program. So this repetitive operation is done using the loop control structures in C or any other programming language. So in C there are three types of loops. The first one is the for loop or the for statement, second is while loop, and the third is do while loop. So three types of loop structures are there. So in general, what does a loop do? A loop is used to execute a block of statements repeatedly until a given test condition becomes false. That is, as long as the test condition remains true. As long as some condition is satisfied, the statements will keep on executing themselves repeatedly. So the block of statements that are executed repeatedly in a loop are together called the body of the loop. So the loops can be classified further into two categories: entry controlled loop and exit controlled loop. So in entry control loop, what happens? The test condition is evaluated first. If it is found to be true, then the body of the loop is executed. If it is false, then the execution of the body is skipped and the control goes to the statements following the loop, right? And in exit control loop, the body of the loop is evaluated first and then the test condition is evaluated. If it is true, then the body is executed again, and if it is false, the control goes to the other statements following the loop. So the for and while loops are entry controlled loop, and the do while loop that we will be doing is exit controlled loop. So for today's lecture, we will be taking for loop. The general syntax for the for loop is for within parenthesis initialization, then semicolon, then test condition, another semicolon, and after that increment or decrement statement, and then comes the body of the loop within parenthesis. So if the body consists of only one single statement, in that case parentheses are the braces are not necessary. So if there are more than one statements to be executed inside the for loop, in that case we have to use the braces. So to understand for loop, let us have a look at the following. For I equal to 1, I less than 10, I plus plus, printf I equal to %d\t, comma I. So what does it do here? The variable I that we have written is called the counter variable. It is used to control the execution of the loop in a smooth way. So the assignment statement I equal to 1 initializes the value of I as 1. So at the beginning of the loop, the value of I is assigned as 1. Then I less than 10, this is the test condition. This I less than 10, this one is the test condition. And as long as the value of I remains as 10, the body of the loop will be executed. So the test condition is I equal to 10. So here I have written, so the loop will keep on executing as long as the value of I remains less than 10, as long as this condition is satisfied. And I plus plus, the statement I plus plus, it increments the value of I by 1 after each execution of the body of the loop. So the increment statement I plus plus increases the value of I by 1 after each execution of the body of the loop. So the above code will work as below. Start with I equal to 1, then it will check whether I is less than 10 or not. So here I equal to 1 is obviously less than 10, so this condition is satisfied. So this condition is satisfied, that is yes, so it will go here, and then it will execute the body of the loop. After that, the control will go to the increment statement. The value of I will be increased by 1. After that, again the test condition will be tested. So once we increase by 1, the new value of I becomes 2. So 2 is less than 10, that is again true. So it is satisfied. Again this body will be executed. Again the value of I will be increased by 1, that is I becomes 3. But I is less than 10, this condition is already satisfied. So again this is yes, so the body will be executed again. So this way it will continue till the value of I reaches say 9. So 9 is less than 10. This is again satisfied. So it's yes. Again the value of 9 will be printed, and again the value of I will be incremented by 1. So new value of I becomes 10. So is 10 less than 10? So that is no, incorrect. So the loop will stop. So this is how the loop works here. Okay. So in a loop, the test condition is evaluated first. In a for loop, the test condition is evaluated first, and then the body of the loop is executed if the condition is true. Hence, for loop is a entry controlled loop. So let us have a look at some of the programs written using for loop. So this is a program to find the sum of the first n natural numbers using for loop. So we start with int I, integer variables I, n and sum. So the variable I will be used to control the execution of the for loop. Then n will give us the value up to which we want to find out the sum. So the value of n is entered by the user. So we initialize the value sum to 0. So there is a reason for doing this also. And then we begin the for loop for I equal to 1. This is the initialization. This is the test condition. We have to find out the sum up to n natural numbers, and then I plus plus. Sum takes the value of sum plus I. So this means new value of sum is old value of sum plus I. Okay, so that is what happens. So printf sum of first n natural numbers is sum. Okay, this will be printed. So note that the body of the loop here has only one statement. Hence braces are not required after the for statement. So just quickly let us have a look. The program runs somewhat like this. Say we enter n as 5. So initially the value of sum is given as 0. So when I becomes 1, at the beginning of the execution of the loop, the value of I is initialized to 1. So the test condition is checked whether I is less than or equal to 1. So in this case it is true. So new value of sum will be old value of sum plus I. So what was the old value of sum? It was 0. New value of the current value of I is 1. So the new value of sum will be 0 plus 1, that is 1. Then the increment will be evaluated. So the value of I will become 2. Again the condition will be tested. So in this case it is true. So the new value of sum is again old value of sum. Old value of sum means the value that is obtained in the previous step plus the current value of I. So that is 1 plus 2. So again I plus plus gives the increment as I equal to 3. Again this condition is satisfied. So the new value of sum becomes old value of sum. Old value of sum is 3 plus the current value of I. Okay, so that way when I becomes 4 is less than or equal to 5. This is still true. So the sum is old value of sum, that is old value of sum is 6, and then the current value of I is 4. So it's 10. So that way it goes up to 15. So when the value of I becomes 6, in that case this condition is false. So the loop is exited. Hence the final value of sum is 15. Okay. So let us have a look at this program. We have written this program here. This is program number 7. Program to find the sum of first n natural numbers. So this is the program. So let us see how it runs. So it's /program 7 for loop. Enter the value of n. Suppose I enter n as 5. So sum of first 5 natural numbers is 15. Enter say n as 100. So it should be 100 into 100 plus 1 by 2. So 101 into 50. So that's answer is 5050. Yeah, so the thing is correct. That is how the program works. Okay. Right. So let us have a look at another program that we have here. Program to find the sum 1 plus 1 by 2 plus 1 by 3 up to 1 by n for any given value of n. So in that case we use integer variables I and n, but in this particular case the sum is taken as a floating point number. floating point variable, because 1 by 2 will be evaluated as 0.5, so it's not an integer. So printf enter n, just as before. So the loop is also similar to the earlier one. So in this case, sum takes the value of sum plus 1.0 by I. So we have given 1.0 because if we give 1 by I, then both the expressions will be integer and the value will be evaluated as in integer. So 1 by 2 will be evaluated as 0. So we don't want that. That is why. So printf, the value is this. So observe that the condition. So here we have made a slight change in the condition. In the earlier case, we had written I less than or equal to n. In this case, we have written I equal to I strictly less than n plus 1. So these two conditions are equivalent. So we can use any one of them. So also note that we have written 1.0 by I. So already I have observed that. And we run this program. So let us see how this program runs. Yeah. So this is the program that we have written. So let us run this from 8. Enter the value of n, say 5. So it's 2.28334. So it's 3. So it's 1.8333. Okay. So let us just verify that whether if we write 1 by I, what happens. So GCC, let us compile this. GCC 8. Yeah. So we have compiled it. Let us run it again. We have modified it to 1 by I. So let's say 2. So in that case, you see the answer comes out as 1. But actually it should have been 1.5. So why this is happening? Because we have written 1 by 5. So sorry, 1 by I, and this expression gives you only integer arithmetic. That is why you have to give it 1.0 by I. In that case, it will work fine. Right. So suppose, yeah, now it works fine. Okay. So let us have a look at another program. Program to print the multiples of 7 less than 1000. So this is a very simple one. Integer I. So this will keep. This is the counter variable that I am using. So printf multiples of 7 less than 1000 are. So we start with I equal to 1. And instead of giving the condition as I less than something, we give the condition as 7 star I. Any multiple of 7 is 7 multiplied with I. Okay. So we want multiples of I less than 7. So 7 multiplied with I should be strictly less than 1000. Once it crosses 1000, we'll stop. So this is the test condition, and then printf %d backslash t. Backslash t is given just to create some spaces so that the numbers are distinct. Okay. So let us see how this program runs. So this is the program. Multiples of 7 less than 1000 are this. So let us run this. 9. So these are the multiples. You can see 7, starting from 7, 14, 21, 28 up to 987. These are the multiples of 7 which are less than 1000. Okay, now instead of less than 7, instead of backslash t, if I do not give anything, then what happens? Just let me show you the importance of this backslash t here. 9. So we have compiled it again. See what is happening. The multiples of 7 less than 1000 are. The program is running fine. The output is also okay. But what is the problem? There is no space between 7 and 14. No space between 14 and 21. So you are not being able to identify what are the numbers. Okay. So that is why backslash t is very much necessary here. And that is the reason for giving backslash t. So it has to be backslash t or backslash n. If you want backslash n, the outputs will be printed in the next lines. Right. Let us have a look at another program. we can write the same program using a different logic. Just let me edit this. Instead of writing 7 star I less than 1000, we can do it this way. We can keep this condition blank and keep on increasing the value of I, and then we can give the test condition here. Or we can start with, say, 7 for I equal to 7, and instead of giving I equal to I plus let us give it as I equal to I plus 7. Okay, and for I less than 1000, right? So we don't want this if statement, so we can write the program this way also. Printf %d \t, instead of 7 star I will just write it as I now. Okay, so what I have done, I have just changed the initial value of I. So we start with 7 right away. We start with 7, and then we check the condition that whether I is less than 1000 or not, and each time we increment the value of I by 7. Instead of incrementing by 1, the next multiple of 7 is obviously 7 plus 7. Okay, so let us see what happens here. So /program9, so the program is running fine. So there are several ways we can write the same program. Okay, so let us see another program to display odd numbers between a range of integers. So what it says is you have to display the odd numbers between any two given range of integers. So suppose L and U are the lower limit and upper limit. So we write something like enter the upper and lower limits. So we take the values of U and L as input, and the odd numbers between L and U are given by this. We start with I equal to L, and then test the condition as I less than or equal to U, and then I plus plus. If I %2 not equal to 0, so because we want odd numbers, so we have to test this condition whether the remainder when I is divided by 2 is non-zero or not. If it is non-zero, then we will print. So if I %2 not equal to 0, then print this. If it is 0, then do not do anything. Okay, that is how we have written this program. And so let us see how this program runs. This is the program, upper and lower limits. So let us see. Enter the upper and lower limits. Suppose I enter 2 as the lower limit and say 50 as the upper limit. Then odd numbers between 2 and 50 are 3, 5, 7, 9 up to 49. Okay, so let us run this again and see. Suppose I write with say 3, and the last one is 99, so it's 3 up to 99. Okay, these are the odd numbers between 3 and 99. So if you want to exclude the lower and upper limit itself, excluding L and U, you can start with I equal to L plus 1 instead, and here you can give I strictly less than U. So we can write something like this. If we want to exclude L and U, so we start with I equal to L plus 1, and then write I strictly less than U I plus plus. Okay, so this will give you the code when you want to avoid this L and U. So for this particular program, you see that brackets or braces were necessary for this body of the loop, because there are several statements inside the body of the loop. So in this particular case, we have to provide the braces. Okay, so these are some examples of for loop. In the next lecture, we will write a few other programs to illustrate the use of for loop, and then we will also see that in for loop, if you exclude any of these three conditions, then what happens, and what are the conditions under which the for loop may run into an infinite loop. Okay, thank you.